In this video, I'm going to talk a little bit about water and its polarity and how that's related to all the properties of water. So you already know that water is very important for living things. You probably know that you're about 2/3 water. You know the planet is 2/3 covered in ocean. You know water is important to keep you hydrated, but there's a lot of other properties of water that make it essential for life. And a lot of it is related to the shape of water. So that's what we're going to talk about in this video. If you haven't taken chemistry, you might not know that water is a bent molecule. It's bent because the oxygen has a couple of lone pairs of electrons, and those lone pairs push the bonding pairs away, which make it bent. Now you might remember back in grade 9 and 10 when you learned about bonding, you learned about covalent bonding. And you might have remembered that that means electrons are shared between nonmetals. The co means together, and the valent refers to the valence shells. So the valence shells together, that's what covalent means. So water is a covalent molecule. These are covalent bonds. So these lines represent shared electrons. But one thing you didn't learn in grade 10 was that these electrons are not shared equally between the oxygens and the hydrogens. Some atoms have a stronger attraction for electrons than others. That attraction for electrons is called electronegativity. So let's say in an atom like fluorine, which has 7 valence electrons, and it's a very small atom, it's going to have a very strong attraction for electrons. The fluorine is extremely electronegative. On the other side of the periodic table, metals like potassium. Potassium loses electrons very easily. It does not have a high electronegativity. So back to water, oxygen has a higher electronegativity than hydrogen, which means that these electrons get pulled closer to the oxygen. Okay, so the negative charge, that's the electrons, gets pulled closer to the oxygen. So we can represent that with an arrow, and then we put a little line through the arrow, and this looks like a plus sign, which can tell you this is the positive end. So in other words, if the negative electrons are being pulled closer towards the oxygen, it makes kind of a negative end to this molecule. And so we can also represent that with a Greek symbol delta negative, and then if the electrons are being pulled away from the hydrogens, these would become more positive ends. So even though the entire molecule is neutral, it has a negative end or negative pole and positive poles. So we would say that water is polar. Okay, and this is really important. If it wasn't for this property, we wouldn't have water drops. Because the fact that it's polar means that if there's another water nearby, another molecule, and we've got our negative pole and our positive poles, this positive pole is going to be attracted to the negative pole of an adjacent water molecule. And this is a bond. It's a temporary bond that forms, but it's called a hydrogen bond. And this is different from the bonds you've learned about before, because this is a bond between molecules. Right? The bonds you've learned about, like ionic bonds and covalent bonds, are within a molecule. These bonds between molecules are called intermolecular. Inter means between. Intermolecular. And so it keeps water molecules attracted to other water molecules, which explains some of water's properties like high surface tension and cohesion. Cohesion means how water molecules stick to each other, and adhesion, which means that water molecules will be attracted to other things. So for example, the fact that water can travel up the tissue of a plant, all the way from the roots, all the way to the leaves up at the top. How does it climb up through that vascular tissue called xylem? It travels up through there because of the fact that water is cohesive and adhesive. Water is also very good for dissolving things in, makes it a good solvent, and one of the reasons is because of these poles. So if you have a positively charged ion like sodium, it's going to be attracted to the negative pole of a water molecule. Okay, that's not a hydrogen bond, but it is attracted to the negative pole. And if you have a negative ion like chloride, well, it's going to be attracted to the positive pole of water. So if you put a salt crystal in water, the water is going to rip the salt crystal apart. It's going to dissociate because the ions are attracted to the different parts of the water molecule. Okay. And because things dissolve easily in water, it's well, for example, in your circulatory system, most of your blood is water, and it's good at dissolving things and carrying those things around your body. Okay, so there's some other properties of water too, such as surface tension and specific heat capacity. It takes a lot of energy to boil water. Again, that's because to boil water, we have to add enough energy to break these hydrogen bonds. Okay, so this is just as an introduction, and you're responsible for knowing about those different properties of water. But you can relate them all back to the fact that water is polar, and it's polar because it's a bent molecule.